But what are NADH and FADH₂? Now, I don't expect you to know these medical or these chemical structures at this level. And actually, maybe in biochemistry we might test you, but even then, it's not so much about what they look like, but what they do. So, what's their main purpose? Well, they store electrons and protons released by the citric acid cycle. And the thing is that these stored electrons have energy. These bonds have energy. And you can use this energy to make ATP. Now, let's see. Okay, so this is what happens. This is the reactions that happen when they store these electrons and protons. So we have to talk about something called oxidation and reduction. And if you haven't had chemistry before, this is probably going to be like, wait, what? So oxidation and reduction is when a chemical loses electrons overall, and then reduction is when a chemical gains electrons. And this is where it's kind of counterintuitive at first. We're like, wait, reduction? I usually think of reduction decreasing something. So you're saying it gains electrons, but it reduces as a reduction. Well, reduction refers to the electrical charge of the molecule in this oxidation reduction. I know, why didn't they call it like couldn't they have called it like oxidation and electronification or deoxidation? This is just what they went with. You just got to get used to it. So this is a way to think of it. Reduction is reducing the charge. So when you reduce NAD plus, it goes from a positive 1 charge to NADH with 0 charge. So you're going from +1 and reducing the charge to 0. And why is that? Well, all the way back to basic chemistry, electrons have a negative charge. So when you gain electrons, the charge of a molecule drops. Oops. So if you have Friday lab, by all means go to Friday lab, and I'll try to end with maybe with the electron transport chain. So if you can hang on, by all means please hang on. So what's happening as you go from here to in both of these equations, if you go from this point A to point B, is that you're reducing because you're gaining electrons right here. So this is why it goes from +1, or actually it's like +2, because you have +1 and +1, but you're also subtracting 2 when you gain the electrons. This is why it goes from positive to negative, or to neutral. FAD is like, okay, why doesn't it become FAD -2? It also incorporates some protons as well, and protons have their own charge as well. So the protons and electrons cancel each other out. This is why FADH₂, even though it's gaining electrons, there's no overall change as it goes from FAD to FADH₂. Now, nicotinamide adenine dinucleotide, I rarely hear it referred to as that. Most people say NAD. So this is what's happening here. So this is NAD plus, and I'm just putting the 1 here just to say like plus means it has a charge of +1. So this is the oxidized form, and then it has a positive charge. Now what happens when it gets reduced is that it gains electrons. So what's going to happen is that it also incorporates a proton into its chemical structure. And what happens is that you also add 2 electrons. So these electrons and the proton also help to form new bonds as well. So what you end up with is, when you reduce NAD plus, is that you gain 2 electrons, and you also incorporate a proton in it as well. So this is why these molecules are important. They're ways of storing both protons and electrons. And NAD, this is why you go from NAD plus to NADH. These electrons reduce the overall charge of NAD plus. Now, FAD, flavin adenine dinucleotide. Not so much worried about the full name, just know FAD. So FAD is the oxidized form. What happens here? It gains protons and also gains electrons at the same time, actually an equal amount of electrons and protons. So the electrons and protons cancel each other out. This is why there's no change in the overall charge, but as you go from the oxidized FAD to the reduced FADH₂, you're storing these electrons, you're also storing protons as well. So again, it has no net charge in both the oxidated and the reduced form, but what's the difference? Whether you have electrons and protons stored or not. And this is a handy dandy mnemonic. I learned it from like another, what year was that? I forgot what year. But I like this one. So what is this over here? This is an oil rig, and this is a mnemonic. So oxidation is losing, and was it losing? Electrons, and reduction is gaining. So you're gaining electrons. So whichever sticks in your mind, just remember that reduction doesn't refer to losing electrons. It actually means you're gaining electrons. Reduction refers to the overall charge of the molecule. Now let's see. So again, NADH and FADH₂. So I didn't spend a lot of this, and why didn't your cells generate just ATP from the start? Well, things that NADH and FADH₂, they still have energy, but not in ATP form, and they're more stable than ATP. So the thing is that we kind of went from glucose, which has, compared to a single ATP molecule, has a lot of energy. So to use that energy and currency and value analogy, so glucose is like having like something like gold, right? But is it that final cash form that your cells can easily use? Not quite yet. You have to convert it to ATP somehow. So I like to think of if ATP is like currency and cash, well, I like to think of NADH and FADH₂ kind of like something in between. So a little easier to use than glucose by itself. But what you're doing is like you're kind of taking the value from the energy from glucose, converting it into a more easily used form, but it's also a stored form as well. But the thing is this the most easily used form of energy? Not quite yet, but it is a very useful storage form. So this is the main purpose of NADH and FADH₂. They're storage form for energy that your cells can use for later. Because again, your cells can crank out a bunch of ATP, but it's not going to last very long in your body because ATP is inherently unstable. So where do NADH and FADH₂ go? And they go from the citric acid cycle. So again, we generated a bunch of NADH and also FADH₂. And they go into the electron transport system. So this is where they go to.